Good afternoon and welcome. I'm David Feist, and I will be the facilitator of this webinar today. Our presenter is Jeanné Mensingh. Thank you for joining ANAB for our complimentary webinar on data integrity and ethics. Please note we are recording this webinar, so it will be available for viewing in the future. As we go through this, some logistics before we get started. Due to the high attendance, everyone will remain muted for the duration of the webinar. Please enter your questions into the Q&A box. We have planned time at the end of the webinar to answer any questions. Now, a short disclaimer. The content delivered in this webinar is not guaranteed to fully prepare attendees for any specific application for accreditation. Attendees are, of course, responsible for determining the applicability of the information presented to their specific circumstances. The examples provided in this webinar are strictly for illustrative purposes only and are intended to facilitate the understanding of those concepts discussed. They're not to be interpreted as templates, prescriptive models, or representations of compliance with any specific standard. So I'd like to tell you a little bit about our presenter today, Jeanné Mensingh. She has vast background and experience. She co-founded and is a principal consultant of Labtopia. She has well over 30 years experience in laboratory manufacturing, assessing. She has a BS in chemistry. It's easier to tell you what roles she has not done than what she's done, as well as the industries that she's served. We are very fortunate to have her doing this presentation today. Jeanné,
Thank you,
this is
David.
yours.
All right. Well, first we're going to talk about some basic concepts and definitions, and we're going to address ethics first. And we're going to talk about basic ethical principles as it relates to your day-to-day activities. And I'm going to pull those principles and associate those with data defensibility as well as we go through. The first one is autonomy, which is self-determination. It's really autonomy means that there is an absence of controlling influences. So we see that as, no conflict of interest. The lab analyst or the person performing the task is protected, kind of like in a bubble where there could be no undue pressure. So autonomy is very important in relations to data defensibility. Beneficence is to do good. That's the definition of beneficence. As it results related to basic ethics is the intent and the understanding of not performing or doing anything to cause harm. It's to do good, to do the right thing. Non-maleficence, and I always think about Maleficent and Disney related to this, but non-maleficence means to do no harm. This also means to prevent harm from occurring to others. And you would think, how does that relate to data defensibility? Well, if you're working in a regulated industry or an industry that helps or provides results that could impact public health, that would be very important in our role in that in data defensibility and data integrity is to do no harm and to prevent harm from happening to others. Justice, of course, is fairness and also our responsibility to protect and defend the rights of others. And in doing so, by providing accurate results, performing our jobs as we are trained to do and to follow our SOPs, and to apply that with the knowledge that we are protecting and defending those rights of others in relation to how our data is used by that end user. Fidelity, keeping our promise. Of course, this means that we're going to perform our test or our task and record those results and data and evidence according to our procedures. And we're not going to deviate. We're going to perform those as we have been taught and always keep our promise to do the best job. And then our final principle that we're going to talk about related to ethics is veracity, which is honesty. And this is our duty as scientists and operators and analysts and working in either a lab, manufacturing, a clinical trial, and any type of work that you might do that is regulated or even non-regulated, is to do that work honestly and to report those results as you found them. Now, once we have our basic ethical principles, we need to talk about data integrity. So first ethics, now we're going to talk about data integrity. Data integrity means that we have complete data. So this means that data that is retained is prevented from any changes, it's complete, it's available, accurate data, and then of course quality of the data. And that accuracy, completeness, and quality is all over time and across all formats. The formats could be manually recorded, it could be electronically recorded. Wherever that data exists, it maintains its integrity. So when we interpret that data integrity, we have to be sure that we apply that wherever that data exists. And including, I mean, emails, uh, your databases that you retain that information, the paper that you retain, the scans that you make, all have to be complete and accurate. And then now we need to put those two concepts together, which is data integrity and ethics. And that leads us into legally defensible data. And I'm going to talk a little bit about that as well. Also, the intent to protect others and accurate and consistent data. Let's go back to legally defensible, because the purpose of data integrity ethics is to have that legally defensible data. And I've always told analysts and when I've worked in industry, you know, your product is the data that you provide, those results that you issue out. And I always say, when I have a new analyst, is I say, how would you feel? And we can talk about pH, probably one of the simplest things for the test to do is how would you feel standing in front of a judge or standing in front of your peers or your customer and say with 100% total commitment on your part that that data is complete and accurate and it has quality behind it and it's legally defensible, that you feel that you have enough records to support anything that you wrote down related to that data. And that truly needs to be when you're presenting that data, that's the legally defensible part. And all the tools that you have related to help you support to maintain those records, to have enough records, enough measurement traceability, and to document what activities occurred at the time that they occurred provides that legally defensible data. So that's how important data integrity and ethics ensures that you get that data. So now we've talked about data integrity and ethics, let's look at the other side of that and while we're talking about and defining these things, and that's laboratory improper practice. And this can be applied to improper practice to any type of industry, laboratory, task, manufacturing, operation. But laboratory improper practice or any kind of improper practice is the divergent from that required methodology. In other words, a deviation from following your own procedures or the requirements or the contract or the standard or the regulation that you adhere to. It's a complete deviation either from not following those procedures and SOPs, not having the quality assurance, in other words, the QC, the other tasks that you perform to support good results to show that they are valid, traceable, complete, and accurate results, and also good laboratory practice. So now that we understand improper practice, there's two types of improper practice. It's unintentional and intentional. And we're going to talk about each one of those. So when we talk about intentional well, let's go back to unintentional. I would like to go back to unintentional. For unintentional improper laboratory practice, it's typically based on the fact of not having prior knowledge, an ignorance of what the tasks are required, just poor communication, and understanding what the end result and the impact of those results will have. So I might, you know, deviate from my procedure, not intentionally to cause any issues, but just because it might be the practice, it might be the culture, or it just might be a lack of understanding on my part. Now, when you move to intentional, then we start moving into the F word, which is laboratory fraud or any type of fraud. Intentional is the deliberate falsification of analytical and QA results to make failed results or any results appear acceptable when reporting data. Acceptable. So this is the deliberate falsification. So it means that I have deliberately deviated from a procedure, and I'll provide an example for that, and or I've intentionally recorded data that didn't exist. I dry labbed, or I changed data like pencil whip data to where it met any requirements. And I'll give a couple of examples for that. So let's talk about intentional deviation. So I'm working late at night and I have a deadline. Oh, I have some undue pressure to complete a task, and I'm running my samples, and I know I can save time and get home, which is really where I'd rather be versus working late, if I just kind of shave off some time either on the preparation part of that test or maybe skip a few steps, and it wouldn't be really noticeable. And I don't have to, I can just do it and present those results. That's an intentional deviation, a deliberate falsification. The fact that I concealed it and I took shortcuts, so I deviated from it, made it intentional. Now, intentional recording or transcribing incorrect data could be something as simple as it's my responsibility to come in at 5 o'clock in the morning and take temperature readings on all our equipment, incubators, ovens, refrigerators, and everything. And I really need to get through because I have a big list of things that I need to get through today. So I might go through and say, what's a little thing? I know that the temperature is supposed to be around 3 degrees. So I'm just going to record 3 degrees. And if just by doing that, we've now deliberately falsified data on that part. So it may not, from a result that might be really complex and have a lot of impact to something so simple as just a temperature reading that may not have any impact, but both still constitute laboratory fraud. So now that we've had some improper practice and fraud, what's some of the consequences that can happen from that? And that's debarment. And sometimes we don't really understand, or I found that a lot of people do not really understand what is debarment and what does that impact from that. And it has no, it can actually impact the organization and also the individual or individuals that took part of that falsification or fraudulent activity. It occurs in the Office of the Inspector General, and it's for any regulated industry, like FDA or EPA are just examples. They both have the Officer of the Inspector General. And you can actually go in and do a search and look at firms that have been debarred and persons. And when that occurs, when that debarment occurs, from whatever activity, which could be an environmental crime, can be contract fraud, could be mail fraud, embezzlement, theft, a whole list of items, false statements. And I'll talk about some things in the news. One of those was Flint, Michigan, where they had the lead issue. Then you can get into the realm of debarment, and debarment can be a day, it can be a month, or it could be your entire career. And that means that you would be prohibited from working in the industry and the testing and the activity that you were doing for that time period that you're debarred. And it's a hefty consequence, not including other things that could happen from fraud. But I thought it was very important to mention about debarment. So now that we've kind of got the basic principles and definitions related to improper practice, fraud, data integrity, and ethics, and what some of the consequences would be, let's look at some of the standards and regulations that are out there. And there are several different regulations with data integrity requirements, and these are not all of them. I mean, we'll talk about some of the others as well. So the first one could be EPA, and this would be any state regulations. It could be federal regulations. It could also have standards like the TNI standard or other types of standards that laboratories are held accountable for in order, and especially when dealing with public health and the environment. Another one, of course, is FDA for pharmaceutical, med device, cosmetics, and also GLPs, GMPs, and all the GXPs. And those are all the different types of regulations. And for those, of course, are considered as laws and regs that you have to comply with. And all of these do mention data integrity, either in terms of, it could be anywhere from clinical trials all the way to R&D and the first steps in moving a drug product in to actually issuing out the drug product and manufacturing and everything in between. The next is DoD and DOE, Department of Defense and Department of Energy. And this is related to regulations for doing work with the government for those particular entities and their standard, which is the QSM, which has an emphasis on data integrity and activities. And actually, the latest version has quite a bit extensive examples, if anyone would be interested to go look at those, on what it constitutes improper or prohibited actions in the laboratory. And when we get to others, on that other industries, it's food industry, of course, with all your food regulations, and it could be in terms of all the way from your Department of Health for food preparation through manufacturing, distribution, all of those for the food. And the other one that I thought of too is the automotive industry in terms of safety and recalls. And all of those had to do with their requirements to report activities that might have been construed as issues with their data or what happened with their products, and to report that to the public and to be transparent about it as part of our honesty and veracity related to our ethics for that. Now let's kind of look at some types of fraud. And there's actually about two types of fraud. And I want to ask you, and I want you to think about, how would you detect these types of fraud? There's procedural and there's measurement. And procedural, I'll give some examples. Of course, we talked about deviating from our SOPs, shortcuts, deviations. Post spikes means that we are kind of adding additional uh, uh, compounds to our spikes or our QC, or just changing our QC values in order to get good recoveries. And also skipping steps, just totally just skipping a step in a procedure at that, and how that would impact that. Measurement types of fraud can be terms of how you manipulate your data. And that could be manual integration activities that are incorrect. Manual integration is okay, but there are certain requirements related to manual integration and being consistent and accurate with those. Time travel, um, putting something in place to make it look like it occurred at a time that it didn't. And in all standards, it always states to represent the date and time and the activity at the time that it was done. So that means not changing dates to appear that something was done sooner or later, or also in terms of like a sample might have been sampled at a certain time, that we want to make sure that those are valid times and that occurred at the time of the activity. Altered response factors or any kind of altered related to your software to impact the data. It could be an example of that would be to reuse a calibration from a previous time or process data against a passing calibration, even though the calibration that you ran associated with the data did not pass. So one of the things I'd like you to think about related to these two types of fraud is how would I really detect these? How would that be easy to actually look at these? And when we talk about doing that detect and everything, is which type of fraud is more difficult to detect. So some things that we can think about for detecting these activities are auditing or monitoring or observation or having some software things. But I can tell you the most difficult type of fraud to detect in any organization is procedural fraud. And why is that? Why? Well, because just like I gave that example earlier on, is having someone that is working late or and they're under a lot of pressure could possibly make a very poor decision to change their procedure. And unless you were actually observing the activity when it happened, and if you have to think about the records that you keep for any activity that you're performing, is are those records complete enough to show that actually what happened? Is there good traceability? And can I determine based on those activities whether or not the steps occurred in the proper order and everything? So that's why procedural is very difficult to detect, because you would have to literally either be there or have some controls in place that would be able to determine if some change was made. An example would be, say, incubation for micro, and you have a set time period that you have to do incubation. We're going to just say 24 hours plus or minus, maybe an hour. So how could we be sure that if somebody put something on and then took something off, well, there may be ways to do that, even in your software systems, to say, hey, when we start this test at this time, it won't allow you to do any data result entry until that 24 hours is up. So there are controls in place that you can do that, and observations. I find as an assessor, sometimes it's literally the observation part, because when you do internal audits, I can't tell you how important it is not to do that at your desk. You can do parts of that at your desk. We can look at procedures, but until you're out there actually observing the activity, you cannot catch when those little steps get missed. And it could be unintentional, because that's either the way they were trained, or, you know, I, I, as an analyst myself, I mean, I know that I don't, if I've learned that procedure and I've been doing it every day for 5 years, I may not go back and look at my SOP. And sometimes over time, just little activities turn out to be a really large deviation. So as assessors, we typically do find those deviations during our assessments because we're observing the activity. And sometimes it's kind of a surprise to say, oh, wow, I didn't know I'd skipped that step. And so procedural fraud, the most difficult to detect, but as you can see, you can put some controls in place to help you do that. So I wanted to provide some ethical issue examples and some things to provide some thought. So these are just a very short list of examples of ethical issues. So we've talked about data fabrication, falsification. I mean, just actually writing data in. In my previous careers that I've dealt with fraud, and I've had to put controls in place to ensure that that would make it more difficult to do. And it also just helps the analyst make good decisions. But it's misrepresenting data, falsifying data, of course, being selective on data to meet some quality control criteria. Now, that's kind of specific, but you can also be very selective on data in a clinical trial, or when you're doing ways of moving uh, some type of product into the market. We don't want to cherry pick that data. We want to have all that data so that we can see how it's acting. So being selective in that data, it could be uh, somewhat improper practice to potentially committing fraud. Intentional misrepresentation of analysis date and time. Already talked about that. Time travel. Manipulation of samples, computer software, analytical conditions. As we've progressed from the 80s on to the present, the software is definitely a lot more complex and sophisticated. There are things in place like audit trails that you can have, and other ways to help make sure to protect that data. Because remember, data integrity, that completeness of the data. The completeness includes maintaining all the records associated with that data, that supporting raw data, all of your supporting documentation and traceability to make that data as accurate and complete as possible. Quality control sample misrepresentation, of course, concealment and failure to report, not only for the person that might actually be um, performing or actually doing the test and maybe deviating, but also failure to report if you see something that might be impacting data integrity and everything. And I know that nobody wants to be that person to tattle on anyone, but it's our responsibility. Remember, as we talk about those ethics and all those principles that we have to, is, is we have to protect and stop harm to other people. So if we're in that type of regulation where it might be impact public safety and everything, it's our responsibility to report those activities anonymously. And I know a lot of organizations have a lot of ways of doing that, and some of them we've actually said, about whistleblowers, and that's kind of similar. But it can also be that maybe somebody needs some additional training. Maybe it's not it's not intentional, it's unintentional. And then, of course, the intentional misrepresentation of other employees' work. That's why we have user IDs and password logins, and we don't want to misrepresent other person's work or enter data in that maybe we are not qualified to do on behalf of another person. So these are just a few examples. Now, red flags. And I want to preface this before I go to the next flag, next slide on the flag, is what are red flags? Red flags are cues to potential improper practice or potential fraud, but that doesn't mean that they are. It's a flag, and over the years, I mean, there's probably a laundry list of over 100 flags that I have, is that it will lead me to the fact to say, maybe I need to look at this a little bit more, or maybe I need to investigate a little bit more. But red flags are those things on day to day that should cue you in your organization of say, we might need to look at this a little better, or we might need to put some controls in place to make sure to help guide whoever is doing that task or that test to in the right direction, so that they're not put in a position where they might potentially make a poor decision related to that. So just as I said, clues, signs, or indicators doesn't mean that it is improper practice or fraud. So let's look at a few. So I kind of segregated these in certain areas, and structural means, just like it means in most of our standards out there, it's the management, it's the structure of how we're organized in our organization. So high staff turnover, now that's not something as an assessor that I'm going to see, but I might see it in terms of there's a lot of new people training. And sometimes I'll even ask, what's the turnover? Is there a lot of turnover? I know you have a lot of new people. So high staff turnover can mean that there's probably might be some issues with training or gaps, or it just might be you've brought in a whole new group of people with different values into the organization, and they haven't, they're not really firmly embedded into that organization's vision and mission. So high staff turnover is kind of a flag, might mean there's something systemically wrong. Excessive overtime. People work a lot of overtime. Of course, as an assessor, I'm not going to know that unless they complain about it. But excessive overtime means that people could potentially make mistakes. Either they're tired or they just don't have the time. I mean, they've done this and it leads to potential mistakes. Repeat assessment findings. And we're going to talk about this again, is a red flag. And that's why they are so serious when you get a repeat finding, because there's been a failure in the system in corrective action, either in follow-up, in the plan of implementation, or carrying it out, or not truly finding the right root cause for that finding. And that is a red flag that there could be some improper practice or issues May not be anything related to those, but that is a red flag. Inadequate complaints handling, and then a lack of a no-fault mechanism. Some, you know, some people say, well, what is a lack of a no-fault mechanism? What could that mean to me when I'm working? And really what that lack of no-fault means, I cannot make a mistake where I work. I'm not allowed to make a mistake. If you're in an organization where it's rigid and it doesn't allow for any human error or mistakes, what's going to happen? Well, typically people hide things. They hide it when they do something wrong because either their job might be at risk or for whatever reason. So that creates an environment of hiding things, not writing things down, and being secretive about it. So it's just a potential. And these are not necessarily things that as an outsider would see, but as an internal person, you can kind of think about that. I mean, do we allow people to make mistakes? Documentation, records, okay? And this is any type of records, electronic, paper records, email records, anything that you would construe as records to support your information, your data, your tasks that you did. So if the missing review dates and signatures, a lot. So I don't mean in the terms of that a lot of laboratories will put a review signature on every single page in a logbook, and they have about 100 logbooks. So what happens? There's no review signatures in the logbooks. So not necessarily in that intent, but it could be that there's like a lack of a review, a lack of either a peer review or a supervisory review, some second pair of eyes looking at that data. Lack of the documented CA follow-up, which is corrective action, which moves us back to those repeat assessment findings. Pristine logbooks. And I have one example, and this truly happened, is I went to do an assessment. It was probably about 15 years ago. And I came into the lab, and this particular lab, and I love wet chem, and wet chem is notoriously messy. We spill things. We deal with a lot of manual work and reagents and everything. But this laboratory, their logbooks were amazing. They were clean. They were well organized, and everyone had perfect handwriting, and there was no errors or obliterations, nothing spilled on the paper. And so I kind of made a comment to the analyst, and I said, you know what, these are pretty. It's pretty amazing that I come into this lab in a wet chem, and the logbooks are so awesome. I mean, they really are beautiful. Everybody has such great handwriting. And they said, thank you so much. We prepared those for the last couple of weeks before you got here. And so what they had done is they had transcribed all their notebooks into these nice, pretty clean notebooks for their assessment. And they opened up a drawer, and there was all the rumpled pages, wet pages, all the logbooks, all the original logbooks in there. And so unintentionally, they had presented the data a certain way, but it wasn't the data that was recorded at the time of the event. So we just kind of shared a little chuckle about it. And I said, hey, why don't we get all these old logbooks out and let's look at them and everything. So little things like that, pristine anything in the laboratory. Unexplained gaps or changes in records, like losing pages or just data missing, should be a red flag. Laboratory practices. So discrepancies in analyst QC performance. That would mean I have 5 analysts, but I've got one that's a rock star. Every time they do any kind of QC, it's 100%, 100%. That should be a red flag. I've got 4 other people that are getting from like 85% to 115%, and it just varies. But I have one person that's spot on 100% every single time. That should be a red flag. Either they really truly are a rock star and they're amazing and they are just that good, or we might have some kind of issue with the data. Same concept with that as 2 perfect QC results. Always having 100% recovery. It always looks good. 0% error, 0% relative percent difference. It's so good. I mean, those should be red flags. Can it happen? Absolutely. It's always statistically probable that you're going to have good results, but it's statistically improbable that those results are always going to be 100% or 0%. Poor housekeeping. I think poor housekeeping in some labs, sometimes real estate is at a very bit much of a premium in laboratories, and they just may not have the space, the bench space. But if I go into a laboratory and it's excessively poor housekeeping, cluttered, unlabeled reagent bottles, just unexpired things sitting on the bench. All of it really kind of lends me to feel that I don't feel very confident that of what they might be producing in that laboratory. And so it should be a red flag that, things should be clean, because also it affects morale in the laboratory and the ability to maintain those complete records. So poor housekeeping is also a red flag. Talked about expired reagents, and then of course unexpected sample results. I know a lot of laboratories use historical results for samples, which is a really good way to look at things, but sometimes you might just get an unexpected result. Does it mean anything all the time? No, because we're only as good as our samples. I know the laboratory is always wrong. I mean, that's just been the age-old thing, that it's the lab, it couldn't possibly be our sample. But in the case where it could be a bad sample, that's okay. But we should look at it. We should do a little bit more in-depth look into those things. These are just examples of flags. I'm sure you could think of many more that could occur in those organizations, but I think it gives you a really good kind of basis to go look. And now, how do we address data integrity? How do we look at it in our own organization, and what do we do to monitor it, to ensure that we have good data integrity and ethics in our organization? And these are just a few. This is not inclusive of everything, but monitoring is very important. Not monitoring in terms of doing a desk audit, or even, going through the records, definitely important, but monitoring by going out and physically observing activities to ensure that things are observed at the time that they're done, and making sure that those activities, and how you do that. Some people internal audits, others are actually just going out and doing observations. Supervisor walkthrough. I can tell you, as a supervisor in the past, I would find a lot of things just making my daily walk through the laboratory and looking at information and talking to people out into the lab. Oversight activities and reviews, and how people provide oversight to those activities. Sufficient supervisors, sufficient oversight of the laboratory, which is the basis of a lot of standards and parts for structure. Training, having good training, having frequent and refresher training. Sometimes we forget that, even though analysts might have been doing it for 20 years, that over time things might have deviated. I can guarantee they'll have to dust off that SOP and look at it. So training is really important. Code of ethics or employee conduct, having them understand what the code of ethics are, what data integrity is, and having them sign off. Sometimes this might be in a company handbook or a company manual, or it could be just a separate item that you're required to do based on the regulation that you're adhering to. Having good policies associated with that, and also reporting any issues or concerns. These are just some ideas on ways that you can actually address data integrity in your own organization. So consequences. We've talked about debarment for the consequences, but I also wanted to kind of bring up, when we talk about laboratory fraud and improper practice, one that it was a very famous one, and it's actually recent, was Elizabeth Holmes and the Theranos. And that had to do with the blood testing. And they actually started that organization in 2003. And then she was actually convicted and sent to prison for 11 years in 2022. So there was a lot of things that happened between 2003, but some of those consequences which came from that is, if you ever happen to just look, and you can Google that and look up the court case and everything, it's all public knowledge, is you won't necessarily see them saying fraud. Okay, they'll talk about fraud, but they're gonna talk about it in a different way, because it's really kind of saying you can't go. I mean, it's what is the proof? What is the records that they did? And so they tied a lot of things to that, even though it ultimately was fraud, and they weren't doing the testing, to mail fraud, which has a lot of teeth in it. So every time data was sent out or a report was made, I mean, it came with a fine, and one of the fines were associated with that. It could have been related to the securities exchange and how they manage their business. So when the organization discovered the fraud, they had to go in and find those things where they can actually do an indictment and find some reason, in other words, to make those charges. So I put some examples like the mail and wire fraud. Wire fraud means sending an email. It used to mean just faxing something. Anything that you send in whatever way that is, it could be by courier, by U.S. Post Office, it could be by FedEx, it could be by email or a letter. It could have the potential, especially if it was fraudulent, that each occurrence that occurred, each email, each piece of paper that went out would have an impact on it. Making false statements, concealing facts, and obstructing federal agencies from doing that. So all of these could lead to debarment, it could lead to fines, and it could also lead to incarceration on that part. So those are some of the consequences of improper practice and laboratory fraud related to data integrity and, of course, our data defensibility. So I wanted to,
Okay.
oh, sorry, go ahead, David. Thank you very
All right.
much.
Thank you, Jeanné. What a great presentation. We've had quite a few questions come through, and we'll get to those after we discuss some additional resources available for accredited laboratories or laboratories seeking accreditation. Obviously, some of the things we have, these webcasts and webinars that we have, these are resources that are available for the accreditation community and for those seeking accreditation throughout. They're free, they're live informational sessions. We have the ANAB blog page, which has a wealth of information related to risk, accreditation standard requirements, etc. And in addition, ANAB offers live, online, and in-person training sessions on a variety of topics. So let's get to the questions that we have right now. Jeanné, there's a question that someone adjusted an oven setting after it was externally calibrated. Is this considered unethical?
That's a good question. I think I would have to understand the context associated with it. If the instrument was calibrated for the settings on the dial and they were just adjusting it based off the temperature that they needed, I wouldn't think that was unethical. But if they adjusted it after it was calibrated and they reset it because the instrument wasn't giving them the correct reading that they needed and they wanted to change that, then yes, that would be unethical.
Okay, thank you. Um, Another question that came in is, how widespread do you believe that data fraud is?
That's a that's a hard question. I do want to say that it was very prevalent in the 80s, late 80s, early 90s. And I think that was because there was a lack of standards associated with it, and it wasn't emphasized in the regulations as much. And I saw a downturn of it, and this could totally be just my opinion and everything, but I can tell you that in recent years, I think that it's been more visible than in the past. And I think that's due to um, I don't know whatever it might be due to, but it could be due to new people coming into the job, not understanding the lack of training. I think a lot of it has to do with training and expectations of that. So I would say that it's not rampant out there, but I do think that there's always a potential for um, improper practice, even unintentional improper practice due to a new workforce coming in or high turnover, which I think that a lot of organizations have had a lot of problems with in the last few years.
Okay, thank you. Um, Another question. Do you believe that data integrity is primarily the operator's responsibility?
No, I think it's across the board. It's the management for ensuring that that operator has the right environment to do the right thing. And I mentioned it earlier in the presentation, it's all about making good decisions, right? And if you don't provide the environment for the operator to make those good decisions, and that means that undue pressure not protecting them, not providing the training so that they do understand those requirements. It's not, I mean, you don't know what you don't know. So I think it's a concerted effort between everyone in the organization to have that same mindset and ensure that it happens for those operators that are coming in.
Okay. Jeanné, as a follow-on to that, they also wrote, are operators responsible for the consequences of unintentional deviations they cause?
Huh. Well, another thing would be context. I can tell you that according to when we talk about debarment and we talk about the potential for charges, is you're responsible for your actions. Now, in terms of the investigation where it was either unintentional or intentional, that would have to be determined. I mean, then it would be based on what level of responsibility would that be. I would say if that was a case for me and maybe I unintentionally did something incorrect, is I would question is, did I have the procedures in place? Did I get the right training for that? Were there systems in place to ensure like checks and balances, like reviews and everything, and feedback to help me do my job better? So I think once again it kind of goes back to that concerted effort that it's everyone's responsibility. Can people make the poor decision on their own? Absolutely, and be fully responsible. But if it's unintentional, it's just like with when you're doing root cause analysis. One of the things and I hope I'm not going to digress too far, but I think this is important. One of the things in root cause analysis that I see is when people put training. Well, I tell you, that poor person, it must have been trained a billion times because it's always training, training, training. When you do root cause, the first things you should do is try to take a step back and not look at it as a person that did that, but as, is it the method? Is it the equipment? Is it the environment? And I would look at those aspects of it before I even considered it was a human error or a training issue. And I think that kind of goes with the same when you're looking at unintentional as well.
Okay. All right. One final question here. Um, they asked, you discussed quality of data briefly. Can you expand upon that a little bit?
That was a part of the data integrity for data defensibility is you had to have quality, completeness, and accurate data. Quality is what provides your checks for your data. So it would be that quality assurance. What sort of things do I have to ensure that my results are metrologically traceable? What am I using? Am I using certified reference materials? Do I have QC checks? Am I verifying that my calibration is correct? So that quality aspect of it is related all the way back to how good is that result? How accurate is that result? Quality is that supportive aspect of that where I calibrated with the certified reference material. I had a secondary check. I performed checks throughout the analysis. I have other controls, quality controls in place to ensure that that data that I'm generating is accurate and precise to the ability of that instrument with that uncertainty.
All right. Well, thank you, Jeanette. That's very interesting. Um, in reference to this, if you would like any additional information about training offered by ANAB, you can contact us at training@anab.org. And if you have questions about accreditation services, you can contact us at anab@anab.org. There's one additional question that came in if you are amenable to that, Janae.
Absolutely, absolutely. I thought it was actually a good question.
Yeah. When are we not allowed to manually integrate chromatographic peaks?
Very good question. When you cannot manually integrate the when you're doing chromatography, you cannot change those with the intent to get something to pass. When you're looking at chromatography, sometimes it's messy. Sometimes we have a lot of noise and everything. We have to be doing it to be consistent across. So when we're integrating, we want to make sure that we're integrating to have good chromatography. We have good Gaussian peaks. We're going valley to valley, and we're doing that appropriately. When you are not allowed to manually integrate, is if I don't have a passing, maybe I don't have a passing calibration, and I know if I just tweak that peak just a little bit, I can get it to pass. If you're having to make that kind of decision, I would say that I would not be allowed to do that integration. It has to be with the intent that I want to report accurate data. If I manually integrate my calibration or my standard this way, I'm going to apply that same activity throughout the whole process of reporting that data. So it's just a question of why you're doing it and to make sure that you're doing it all for the right reasons.
All right. Well, thank you, Jeanette. For everyone that has been in attendance today and everyone that's not, this webinar will be posted on our website at anab.org. Please feel free to review it there or forward it to your colleagues. That concludes today's webinar. Thank
All
you.
right, thank you.